Okay, welcome back. We're finishing up section 2.02. Now this table gave me a little bit of a confused face the first time I looked at it, but I think I figured it out now. So here's how we're going to do this, right? So for grade 11, let's look at grade 11 first. So let me go. Oops. First, I need to be able to spell grade 11. For grade 11, there are 7 people who have 0 hours of exercise. So that means we're going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. We have 3 people with 1 hour of exercise. We have 1, 1, 1. We have 3 ones. Then we're going to have 4 twos. 2, 2, 2, 2. We're going to have 8 people with 3 hours of exercise. So 8 threes. So 1, 2, 3, 4, 5, 6, 7, 8. Seems pretty complicated. 9 people with 4 hours of exercise. So 9 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 2 people with 5, so 5, 5. We have 1 person with 6, 2 people with 7, so 1 person with 6, 2 people with 7. 2 people with 8, 0 people with 9, so 2 people with 8, but no 9s. 2 people with 10 and 2 people with 20, so 2 people with 10. Oops. So 2 10s and 2 20s. Okay, so let's find out all these values. So we're going to have to find our minimum, our maximum, our median, our first or lower quartile, and our third or upper quartile. So minimum is pretty easy. Minimum is 0. Maximum is 20. Since the highest value, we have 2 people with 20. Highest is 20. The median, all right, obviously that's going to be the hardest one to find. So let's just do, let me take away 5 at a time, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I got these 2 3s in the middle, which means my median must be 3. Now my first quartile, so my first half of the data is going to be everything here. So let's recount these. So we're going to have, let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And go just 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. Okay, so we have a 2 in the middle. It's our first quartile. And then for our third quartile, we're going to have to do, let me just move this 3 over here, make this easier. So we're going to have this. So we're going to have, let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, it looks like we got 5 in the middle. That's our third quartile. Now let me double check that on this because it is a lot of numbers. It's easy to miscount things. So what did they say here? They want us to find our, right here, we want to find the box plot. So we're going to, find all those values. And yeah, our minimum was 0, our high was 20, our quartile 1 was 2, quartile 3 was 5, and our median was 3. And that's exactly what we got. So we did that correctly. We'll make a box plot for that momentarily. The mean, the average is adding up all of those numbers, which I don't know, there's probably like 30 or 40 of them. Add them all up and divide by how many are there in total. So take a calculator and add all of this up together. Let's see what we get. I'm obviously not going to include the zeros, but I do have to count them at the end. So we have 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3 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 plus... Actually, this is probably an easy way of doing this. Let's go back to our table. Let's just multiply. So we have 3 1s, so it's going to be 3 times 1. Then we have 4 2s, so we're going to do 4 times 2. We have 8 threes, so add 8 times 3, add 9 times 4, add, if you're wondering what I'm doing, let me screen snap this so I can explain. Right, so there are 3 people of 1 hour of exercise, so I did 3 times 1. I'm going to add that number to the 4 people with 2 hours of exercise. So I'm doing 4 times 2, and I just keep adding those groups together. So I did 9 times 4, and I'm going to add 5 times 2. Add 6 times 1, which is just 6. Add 7 times 2. Add 8 times 2. There's no 9s, so add 10 times 2. And add 20 times 2. And all together, we get a total of 177. So 177 divided by however many numbers are here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. 42 numbers, I think, in total. So 177 divided by 42 is 4.2 is our mean as our average. And is that what they got there? Yes, 4.2 is their mean as their average. So you can see the numbers already done for grade 12. I'm not going to do those again, but because you saw how I did grade 11. However, they are there. And if we look at the box plots for these, you can see the box plot for grade 11. Let's go ahead and make that real quick. So for grade 11, we're going to have a number line that goes from 0 to 20, since our min was 0 and our max was 20. And we'll go by 2s. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're going to have our minimum at 0, our maximum at 20, our median at 3, our first quartile at 2, our third quartile at 5, and there we go. So we're going to box from the first quartile to the third quartile. So that's going to be from 2 to 5. It's our box. Our median is 3, which is inside there. We have the whiskers that go to the lowest and the whisker that goes to the highest. So there's our box plot. And of course, you can see a better version of that picture here on the graph they've made. And you can see the box plot for 12 as well. Now notice how spread out you see that for grade 11 is. Grade 11 is very spread out. You got that long whisker right there. So when we're going to answer these questions, part 3, what are the best statistics to measure spread and center for each grade? So grade 11, because it has such big outliers at 10 hours and 12 and 20 hours, thus you see that very long whisker, it would be best to use the median and as the measure of center and the interquartile range as its spread, if you will. So you can see that most of the data is concentrated between 2 and 5 hours of exercise. But the outliers pull the standard deviation to 4.4. So again, we didn't calculate the standard deviation, but it is, go back to part 1, they did calculate the standard deviation. You can see that grade 11, its standard deviation is 4.4, whereas grade 12 standard deviation was only 2.2. So grade 12 was more evenly distributed because if you look at grade 12's graph, right, there's nothing it's very symmetrical about it, right? Every section is about the same size, although it's not perfect, it's very close. Grade 11, each part of it is very different than the other part. Like you got that one very long whisker, you've got the boxes being kind of not very symmetrical. So it's not very symmetrical, right? But grade 12 is. So grade 12, you would want to use the mean, and the range. You wouldn't really want to use the median to describe its middle as well. The median is something that you would describe a more grade 11 type of graph, and a mean you would use to describe a grade 12 type of graph. Just because the outliers can really affect that information. The median is not really affected by outliers. which is why median would be great for grade 11 because grade 11 has those outliers and the median is not impacted by that. But the mean, the average, is heavily affected by outliers, which is why, again, grade 11, you wouldn't want to use that mean because the outliers exist. They can really skew that mean quite heavily. But if your data is symmetrical, like grade 12 is, the mean would work out pretty darn well. The mean would be pretty close to, I think, its median. Go back to part 1. Yeah, you can see for, in fact, the mean and median, let me snip this again. Grade 11 is very spread out, remember, and you'll notice that the mean and median are very different values at 3 and 4.2. But grade 12 was more symmetrical, and you can see that their mean and median are pretty much the same thing, which is good. If the mean and median are basically the same, or very, very, very close, then the data is going to be very symmetrical. But if the mean and median are not close together, they're not the same, chances are your data is more spread out. And that spread is shown in the standard deviation. A lower number means less spread. A higher standard deviation means more spread. So things to consider when you're looking at this data. And then page 4 of 5. Oh, it didn't work. Okay, so I've been sitting here too long, obviously. So let me reload this. Go to page 4. All right, you have another activity. It says Moon Beach has a lower median. Half the time attendance is at or below 450. That's good to know. Question. Complete a statistical summary of the data. Include a table and a box plot for your findings. Which beach is most popular and what is the most likely level of attendance at each beach? Explain your reasoning. And then which beach has the least amount of variation in attendance? Now, since I've already explained to you guys exactly how to make a box plot, how to find the minimum, the maximum, the first quartile, the third quartile, the median, all that stuff, I won't show it again unless you request. If you leave in the discussions tab a question you want me to do it, want me to show you this, want me to make a video explaining all of it, I can. But since I've already done that, like I said, I'm going to go ahead and just show the answers here, right? So for a Moon Beach, its standard deviation is 237. Its interquartile range is 410. Now, what that IQR means, that 410, means that its first quartile and its third quartile span 410. So you can see this is at about, I think that bar at the end of the box is at about 290. And here the end at third quartile is at 700. And so that span from 290 to 700, that's 410 values. So interquartile range is 410. So that's what interquartile range is talking about. It's kind of just the range of the box, how long the box is. So you can see in the interquartile range at Dunn Beach Park goes from 300 all the way up to 750. And that's a span of 450. So its interquartile range is 450. Just to quickly explain it, they've got the standard deviation, the mean, and the median. You'll notice Dunn Beach Park has a smaller standard deviation, so it's less spread, whereas the other one is more spread. And then you can compare the mean and median. Now again, if the mean and median are very close together, that's a good sign of symmetrical data. So Dunn Beach Park, as you can see, its graph is rather symmetrical overall. But when you look at Moon Beach, notice how its mean and its median are not nearly close to being the same thing. That would tell me that's more spread out or, very unsymmetrical, asymmetrical. And you can see in the graph that it is pretty unsymmetrical. Okay, asymmetrical, however you want to use it, guys. I'm not an English person, okay? I'm not no English tutor. But there's the boxes for you. So which beach is most popular? And what is the most likely level of attendance at each beach? So for a Moon Beach, because it's so asymmetrical, I would use its median to describe its average attendance better. So its median would be 450 for for Moon Beach. For Dune Park, since it's symmetrical, I would use its mean, which is 504. Now, given that those two comparisons, I would say that Dune Beach is probably more popular simply because its measure of center, which is the mean, 504, is higher than Moon Beach's measure of center at 450, right? So I would say Dune Beach. That's exactly what they said there. So that's perfect. Makes me feel like I know what I'm talking about. Which beach has the least amount of variation in attendance? So again, least amount of variation is a smaller standard deviation. The smaller standard deviation is Dune Park Beach, since its standard deviation is only 207, and Dune Park Beach is more symmetrical. Whereas Moon Beach, its standard deviation is higher, 237, and you can tell its graph is very asymmetrical. So I would say Dune Park Beach is more constant, more consistent, has less variation. And there you go. So the exact same thing that I just said, which is nice. That was just the first example. Of course, there is activity 2, does the same thing. So again, you can see you're working through a summer intern, local university. One of your jobs is collect data about athletes and visitors at games. So you can see athletes and the visitors at the games. So again, I've already showed you how to find the median, the minimum, maximum, median, first quartile, and third quartile. Those values are already given here for the athletes and visitors. You also know how to make a box plot of them, so you could make a box plot, but here it is to show you. And now, question 3: standard deviation of the athletes' data is about 1,196. What does that tell you about the data? So remember, standard deviation is a measure of spread. Now, comparing athletes and visitors, you can see athletes' graph is much more tight and compacted, whereas visitors is more spread out. So what that tells me is that athletes would have a smaller standard deviation than visitors. Visitors would definitely have a larger standard deviation just because it's more spread out. But athletes would have a smaller standard deviation because it's more compact and less spread out. So if the standard deviation is 1,196, that would tell me that most of the data points fall within 1,196 people or units from the mean. That's exactly what it tells you. It says standard deviation of 1,196 tells you that most of the values are within 1,196 points, people, units, whatever they want to call it, of the mean. Although this is a large standard deviation, the values in the data set are all in the thousands as well. This is considered small standard deviation for these data. Yes, given the fact that our numbers in general were in the thousands, our standard deviation being in the thousands is not a surprise. So standard deviation is based on the context of the problem. If all our numbers were in the thousands, our standard deviation being in the thousands is not a big deal. Okay? If all our numbers were like in the single digits, double digits, triple digits, and we had a standard deviation that was, much larger than all the other type of numbers in the problem, then it would be more spread out. But because, like I said, even though our standard deviation is in the thousands here, it doesn't necessarily mean that it's that spread out. Just because all the numbers we were originally working with in the problem are all a bunch of thousand numbers anyway. What was activity 3? So you've got those values again. How would you describe and compare these grades statistically? So middle school and high school. So let's look at them. So I notice, the highest and the lowest scores are not too different between each other. Obviously, the first quartile, third quartile are very similar as well when you compare middle and high school. Interquartile range, median, mean. Okay, so the main thing I notice is the standard deviation. Standard deviation is smaller on the middle school than it is at high school. So that means the middle school is more compacted. Its data is less spread out. The high school's data is slightly more spread out. Yes, and you can tell that from the interquartile range as well. The interquartile range is 13 for middle school, where it's 15 for high school. So a smaller interquartile range means, again, more tightly compacted data. A bigger interquartile range would be more spread out data. So the middle school is tightly compacted because the interquartile range of 13 is smaller than high schools, which is 15, and its standard deviation 7.9 is smaller than the high schools at 8.4. So given its numbers are smaller, it's less spread out. So we can tell that by looking at our data. That's it for this section. I hope it helps you a little bit. Obviously, I'm sure you're going to have plenty of questions, so please ask them in the discussions right there, or feel free to message me. Anything you got to do, I'll leave you guys to it to work on the quiz. Remember, you have 3 attempts on the quiz. Do the best you possibly can. And I will see you in the next section, the next video.